In the 1980s, 1990s, we began to extract high-resolution ice cores from Greenland, from Antarctica,
Yes.
from mountain glaciers, inconceivably fast.
Randall Carlson, renowned for his meticulous research in geology and sacred geometry, has brought to light revelations that challenge conventional thinking about our planet's history. Of particular interest is his deep dive into Antarctica, a continent shrouded in mystery and vital to understanding Earth's climatic past and future. As the icy veil of this remote landmass slowly lifts due to modern exploration and research, Carlson's work emerges as a critical lens, revealing startling truths about Antarctica's role in global events. This video delves into the significant findings and implications of his Antarctic research. Background of Randall Carlson. In the realm of geology and ancient history, few figures stand out with as much intrigue and depth of research as Randall Carlson. With an insatiable curiosity, Carlson has dedicated decades of his life to uncovering Earth's secrets, navigating the fine line between mainstream scientific research and hypotheses that challenge established paradigms. Born in the mid-20th century, Carlson's interest in the Earth's mysteries was evident from an early age. His fascination with natural landscapes, particularly the formative processes behind them, drove him to study the fields of geology, archaeology, and sacred geometry. Over the years, his multidisciplinary approach allowed him to view the planet's history through a unique lens, one that blends the empirical with the theoretical. While his academic journey was not always traditional, Carlson's independent research has been anything but superficial. He possesses a keen ability to question accepted narratives and looks for connections that others might overlook. This has often led him to explore areas such as catastrophism, the theory that Earth has been shaped by a series of sudden, short-lived, and violent events. His in-depth examinations into the Younger Dryas impact hypothesis, which suggests that a massive cosmic impact event triggered sudden and significant climatic changes around 12,800 years ago, is a testament to his dedication to the subject. But what truly distinguishes Carlson is not just his vast knowledge, but his methodology. He approaches his investigations with a rigorous scientific demeanor, coupled with an open-mindedness that allows him to consider alternative theories, even those that may seem unconventional to mainstream scholars. This delicate balance has made him both a revered figure in certain circles and a controversial one in others. Antarctica, in many ways, is a culmination of Carlson's interests. The continent, with its vast ice sheets and hidden landscapes, holds clues to past global events that have had significant implications for climate patterns. For Carlson, Antarctica isn't just a remote landmass at the bottom of the world. It's a living record of Earth's history. Through ice core samples, glacial movements, and geomorphological features, he believes that the continent has stories to tell, stories that may hold warnings for our present and future. One of the main aspects of Antarctica that Carlson has shed light on is its role in past climate shifts. He posits that the melting and freezing cycles of its vast ice sheets have historically been key drivers in global sea level changes. Moreover, his work suggests that the continent may have seen periods of rapid ice melt, leading to sudden global events. These findings, if accepted, could have profound implications for our current understanding of climate change and the potential risks associated with rapid ice melt in the present day. Furthermore, in Carlson's view, the geological features and ice cores of Antarctica might offer insights not just into natural climatic shifts, but also into potential external factors, such as cosmic impacts that could have influenced the Earth's climate on a large scale. Such considerations push the boundaries of conventional thinking but are central to Carlson's ethos: to question, to probe, and to seek understanding beyond the obvious. Geological mysteries of Antarctica. Antarctica is a paradox, a land of extremes that veils its secrets beneath a thick blanket of ice. Today, we know it as the coldest, windiest, and driest of continents, but its geological history reveals a starkly different tale. Randall Carlson, in his exploration of Earth's ancient secrets, has delved deep into this enigmatic landmass, helping to shine a light on a time when Antarctica was a verdant realm far removed from the icy expanse we see today. Eons ago, our planet looked dramatically different. Continents were not in their current positions, and the climate was unlike anything we are familiar with now. Antarctica was once part of a supercontinent named Gondwana, which over time, due to the process of tectonic plate movement, broke apart. Around 200 million years ago, the familiar shape of Antarctica began to drift towards its current polar position. But its journey to the southern pole didn't immediately plunge it into eternal winter. For millions of years, even as it neared the pole, Antarctica boasted a temperate climate. Fossil evidence has provided us with clues of its warmer past. Ancient ferns, trees, and even indications of dinosaur life have been discovered, suggesting that this continent was once a thriving ecosystem, lush with vegetation and teeming with life. With Carlson's interest in linking geological findings with broader planetary events, such discoveries form a crucial part of the puzzle. One might wonder, how did such a drastic transformation occur? How did a land of forests and rivers turn into a barren, icy desert? The answer lies in the intricate dance of Earth's tectonic plates and the evolving atmospheric conditions. As Antarctica moved further south and became isolated by the surrounding Southern Ocean, a cold oceanic current called the Antarctic Circumpolar Current encircled it. This current effectively trapped the continent in a refrigerated state, preventing warmer oceanic waters from reaching its shores. As a consequence, the once temperate climate began to cool, leading to the formation of ice sheets. Over time, these sheets grew, eventually enveloping the entire continent. Carlson's exploration into the geological history of Antarctica goes beyond merely recounting its transformation. He is particularly interested in the cycles of ice buildup and melt, especially in the context of global climate patterns. There's evidence to suggest that Antarctica has not always been as uniformly icy as it appears today. Instead, it has seen periods of significant ice melt and subsequent freeze, mirroring events happening in other parts of the globe. For example, during the Eocene epoch, roughly 50 million years ago, conditions were warm enough for rainforests to thrive in parts of Antarctica. This phase was followed by another cooling period, which once again led to the dominance of ice. But perhaps one of the most enlightening aspects of Carlson's work is his ability to connect such historical climatic changes in Antarctica with global events. In his view, the melting and refreezing cycles of Antarctica's ice have been instrumental in influencing global sea levels and climate patterns. As ice melted, vast quantities of fresh water were released into the oceans, potentially disrupting oceanic currents and impacting climate systems far from the poles. Through meticulous research and a holistic perspective, Carlson brings to the forefront a dynamic and ever-changing Antarctica. His revelations not only challenge our perception of this icy realm, but also underscore its critical role in shaping Earth's climatic past. By understanding the mysteries locked within its frozen heart, we gain invaluable insights into the intricate web of geological and climatic interactions that have defined our planet's history. And in this understanding lies the hope of better navigating the uncertain climatic future that looms before us. Antarctica's role in global climate change. Antarctica's vast, icy landscapes, while seemingly remote and disconnected from the world's bustling hubs, play a pivotal role in Earth's climatic narrative. Randall Carlson, in his characteristic approach of intertwining geological findings with broader planetary dynamics, has amplified the voice of this silent continent, allowing its climatic tales to echo through the annals of history. Through his discoveries, Antarctica's profound influence on past climate events has come to the forefront, shaping our understanding of the fragile balance that governs our planet. At the heart of Antarctica's climatic influence is its enormous ice sheet. It's the largest freshwater reservoir on Earth, holding about 70% of the world's freshwater. Given its magnitude, even minor changes in the continent's ice cover can have major implications for global sea levels. Carlson has often pointed out that throughout Earth's history, periods of significant ice melt in Antarctica have corresponded with rising sea levels, impacting coastlines and ecosystems thousands of miles away. But Antarctica's influence is not limited to its ice. The cold, katabatic winds that blow from its high interior plateau to the coasts play a role in driving the movement of ocean currents. These currents, in turn, are integral to the global conveyor belt, a system of deep and surface currents that regulate temperatures across the globe. Disruptions or changes in the intensity of these currents can lead to significant climatic shifts, affecting weather patterns, precipitation levels, and even the intensity of storm systems. Carlson's research delves into the mechanisms behind such climatic interplays. One of the fascinating dynamics he explores is the interrelationship between volcanic activity, ice melt, and global climate. Antarctica is not just a land of ice, it's also a land of fire. The continent is home to numerous volcanoes, some of which are active. When these volcanoes erupt, they can release significant quantities of ash and greenhouse gases. If these eruptions occur beneath the ice sheet, the heat can cause rapid ice melt, releasing vast quantities of fresh water into the surrounding oceans. This sudden influx of cold, fresh water can disrupt the salinity and temperature balance of the seas, potentially slowing down or altering the path of crucial ocean currents. The ramifications of such disruptions are manifold. As Carlson has highlighted, when these currents are affected, we see a domino effect. Regions that rely on the warm currents for temperate climates might experience sudden and prolonged cold spells. Conversely, areas that are kept cooler by these currents could face unexpected heat waves. Moreover, altered currents can impact marine ecosystems, affecting fish migration patterns and the health of coral reefs. Beyond the immediate climatic effects, Carlson has also brought attention to the long-term implications of Antarctica's changing ice dynamics. In periods where the continent experienced rapid ice melt, the resulting rise in sea levels led to the submergence of vast coastal regions. Ancient civilizations that relied on these areas for sustenance faced dislocation, resource scarcity, and in some cases, complete collapse. Drawing parallels with today's densely populated coastal cities, Carlson's findings serve as a stark reminder of the vulnerabilities we face in the shadow of Antarctica's potential changes. Ancient civilizations and Antarctica. Antarctica, for most of contemporary history, has been viewed as an inhospitable, icy wasteland far removed from the cradle of ancient civilizations. However, with the maverick insights of Randall Carlson, this perception takes a tantalizing twist. He delves into the possibility that the frozen reaches of Antarctica might have once been home to or interacted with ancient civilizations, a theory that could rewrite chapters of human history. Central to Carlson's hypothesis is the shifting nature of Earth's crust, a phenomenon known as crustal displacement. The idea postulates that the Earth's outer lithosphere might shift over the molten asthenosphere beneath it, causing continents to move to entirely different latitudes in relatively short spans of geological time. If true, this means that parts of Antarctica might have been located in more temperate zones in the distant past, making it a viable habitat for ancient civilizations. But beyond mere geological theories, what has truly ignited interest are the intriguing pieces of evidence scattered across Antarctica, some of which Carlson has often referenced in his talks and research. Ancient maps, such as the Piri Reis map of 1513, depict a portion of Antarctica's coastline with uncanny accuracy, a feat ostensibly impossible given that the continent was not officially discovered until 1820. Even more perplexing is that the portion of the coastline shown on this map is currently buried deep under ice, suggesting that the source information for the map must have come from a time when this part of Antarctica was ice-free. Further lending weight to the notion of ancient civilizations having knowledge of Antarctica are numerous myths and legends. Many ancient cultures, from the Greeks to the Maori, have tales of a distant southern land. While it's easy to dismiss these as mere folklore, Carlson posits that such widespread legends might have a kernel of truth, perhaps pointing to ancient maritime cultures that ventured far south and encountered a then less icy Antarctica. Carlson also draws attention to the curious geological and archaeological anomalies found on the continent. Structures and patterns seen beneath the ice, via satellite imagery and ground-penetrating radar, bear a striking resemblance to man-made constructions. While mainstream science often attributes these to natural formations, Carlson, ever the proponent of questioning established narratives, wonders if these might be remnants of ancient human activity. One of the most compelling arguments Carlson presents pertains to the sudden rise of sophisticated civilizations around the world. From ancient Egypt to the Indus Valley, highly advanced cultures seem to have emerged almost out of nowhere, boasting knowledge and technologies that are astounding for their time. Could it be, Carlson postulates, that these civilizations were beneficiaries of knowledge passed down from even older cultures, perhaps ones that once thrived in regions like Antarctica? Of course, these theories, while fascinating, are not without their skeptics. The scientific community, for the most part, remains cautious, often attributing the evidence to natural processes or questioning the veracity of the ancient maps and myths. However, what's undeniable is the curiosity these hypotheses have sparked. They prompt deeper questions about human history, the rise and fall of ancient cultures, and the mysteries that our planet still holds. The impending catastrophe. The enchanting narratives of ancient civilizations and geological marvels of Antarctica, while captivating, are contrasted starkly by the grim forewarnings Randall Carlson brings to the fore. These are warnings of potential catastrophic events intricately linked to Antarctica's present and looming melting patterns. Drawing upon a blend of historical evidence, current observations, and climate models, Carlson paints a vivid picture of the grave implications tied to the accelerated melting of the Antarctic ice sheets. At the center of Carlson's concerns is the sheer volume of ice housed within Antarctica. As the world's largest reservoir of fresh water, even minimal changes in the melting rate can have profound impacts on global sea levels. We are currently witnessing an unprecedented rate of melt. Modern satellite imagery and ground measurements indicate that some parts of the continent are losing ice at almost triple the rate observed a few decades ago. Should this trend continue, or, as some models predict, intensify, we could be looking at a sea level rise that far outpaces current projections. Such a dramatic rise in sea levels isn't merely a theoretical concern. As Carlson emphasizes, history is replete with examples of sudden and drastic changes in sea levels. These ancient events led to widespread flooding, causing displacement of populations, altering of coastlines, and in some cases, the submergence of entire land masses. Given that a significant portion of the world's population now resides in coastal cities, a similar event in the present day would result in socio-economic upheavals of unimaginable proportions. Megacities from New York to Shanghai could find significant sections inundated, causing infrastructure damage that runs into trillions of dollars and impacting millions, if not billions, of lives. Beyond the immediate threat to coastal regions, Carlson's analysis delves deeper into the cascading effects of Antarctic melt on the global climate. As vast amounts of cold freshwater pour into the surrounding oceans from melting glaciers, they can disrupt the intricate balance of oceanic currents. These currents, often referred to as the planet's circulatory system, play a pivotal role in regulating temperatures worldwide. The introduction of cold fresh water can potentially slow down or alter the path of these currents, leading to a chain reaction of climatic anomalies. Regions that have historically relied on warm currents might suddenly find themselves grappling with colder temperatures, affecting agriculture and local ecosystems. Conversely, areas typically cooled by these currents could experience heat waves, droughts, and a myriad of other climate-related challenges. The balance of marine ecosystems, too, could be thrown into disarray, with many species facing existential threats due to changing water temperatures and salinity levels. Carlson's warnings, grounded in rigorous scientific analysis, serve as a clarion call. While the mysteries of Antarctica's past are undoubtedly fascinating, it's the continent's future trajectory that holds the key to our planet's well-being. The intricate dance of ice, water, and atmospheric patterns, with Antarctica playing a central role, will determine the climate story of the coming decades. Modern exploration and the hidden truth. The ethereal beauty of Antarctica, with its sweeping ice sheets and pristine landscapes, has always captured the imagination of explorers and researchers alike. In recent years, the frozen continent has seen an influx of contemporary research expeditions, each seeking to unearth new facets of its rich geological and climatic tapestry. Randall Carlson's groundbreaking theories, often perceived as unconventional, find themselves amidst this vortex of scientific discovery, challenging, complementing, and at times redefining the broader understanding of Antarctica. Modern exploration, empowered by state-of-the-art technology, is unveiling aspects of Antarctica previously veiled in mystery. Cutting-edge satellite imagery, coupled with deep drilling projects and underwater robotics, offers unprecedented insights into the layers of ice, bedrock, and marine ecosystems. Through these sophisticated techniques, researchers are uncovering evidence of ancient freshwater lakes, vast canyons, and even signs of geothermal activity beneath the ice. Such discoveries, while fascinating in their own right, gain added significance when juxtaposed against Carlson's theories. For instance, the revelation of active geothermal regions aligns with his postulations about the interplay between volcanic activity, ice melt, and global climate change. Similarly, evidence of historical meltwater lakes and river systems echoes his assertions about Antarctica's warmer, greener past. However, the true gravitas of modern research in Antarctica lies in its confirmation of some of Carlson's most alarming predictions. Recent studies highlight the increasing instability of major glaciers, particularly those in West Antarctica. The Thwaites Glacier, often dubbed the Doomsday Glacier, is of particular concern. If it were to collapse into the sea, it alone could raise global sea levels by over half a meter, making some of Carlson's terrifying truths about potential catastrophic events all too real. Yet the most profound, terrifying truth emerging from the synthesis of Carlson's work and contemporary research is the sheer unpredictability and non-linearity of Antarctica's responses to global warming. While models and predictions provide a framework, the continent's actual reactions often defy expectations. The rapid calving of glaciers, the formation of vast meltwater lakes on the surface, and the unusual behaviors of certain ice streams all hint at dynamic processes that are not yet fully understood. Carlson's emphasis on the importance of historical climatic events, like the Younger Dryas, finds resonance in these observations. By understanding past abrupt climate shifts and their triggers, we gain invaluable insights into potential future scenarios. The hidden truth that Carlson and modern expeditions seem to be collectively unveiling is the delicate balance and interconnectedness of Earth's systems. Events in Antarctica don't just stay in Antarctica, they reverberate globally, affecting ocean currents, atmospheric patterns, and global climate dynamics. The multidimensional nature of Antarctica's mysteries, spanning ancient civilizations, geological wonders, climatic shifts, and impending catastrophes, positions the continent at the nexus of past, present, and future. While Carlson's theories often challenge conventional wisdom, they also inspire a deeper sense of curiosity, urging the scientific community to probe further, question more, and explore the myriad layers of Antarctica's truths. Consequences and proactive measures. In the unfolding narrative of Antarctica's shifting dynamics, a tale of profound global consequences emerges. The intricacies of this icy realm, as highlighted by both Randall Carlson's theories and modern research, underscore the magnitude of implications for the world at large. But as with any looming challenge, merely acknowledging the problem is not enough. It becomes imperative to envision and enact measures to mitigate or adapt to the impending shifts. The potential ramifications of Antarctica's transformations are manifold. Beyond the obvious threats of rising sea levels inundating coastal cities, the disruption of oceanic currents due to influxes of cold meltwater could trigger wide-ranging climatic anomalies. Agriculture, water resources, biodiversity, and human settlements could be imperiled by abrupt and extreme changes in weather patterns. Economies, particularly those dependent on agriculture or coastal activities, could witness unforeseen challenges, leading to socioeconomic dislocations and potential conflicts over dwindling resources. Against this backdrop, Carlson's voice, both cautionary and constructive, resonates with urgency. One of his key recommendations lies in enhancing global research and monitoring efforts. Given the unpredictable behavior of Antarctic glaciers and ice streams, continuous observation and data collection become paramount. By employing advanced technologies from satellite imagery to deep-sea exploration, a more accurate picture of Antarctica's changes and their pace can be discerned. Furthermore, Carlson emphasizes the importance of historical climatic research. Understanding episodes like the Younger Dryas, where Earth experienced abrupt and significant climatic shifts, can provide vital clues about potential future trajectories and tipping points. Such knowledge not only informs predictions, but can also guide the development of adaptive strategies. On a more practical front, Carlson advocates for the strengthening of coastal defenses worldwide. This entails not just the construction of barriers and levees, but also the restoration of natural buffers like mangroves and wetlands. These ecosystems not only provide a first line of defense against rising sea levels, but also offer myriad ecological benefits from carbon sequestration to biodiversity conservation. Transitioning to sustainable energy sources is another pivotal proactive measure underscored by Carlson. The feedback loop of carbon emissions leading to global warming, which in turn accelerates Antarctic melt, can only be broken by a drastic reduction in greenhouse gas emissions. Transitioning away from fossil fuels, investing in renewable energy, and promoting energy efficiency are steps that can help curb the rate of global temperature rise and, by extension, the rate of Antarctic ice melt. However, the overarching message that reverberates through Carlson's discourse is the imperative for collective global action. Antarctica's challenges are not confined to the continent, they are intrinsically global in nature. As such, the solutions too need to be collaborative and transnational. International cooperation, be it in the form of research partnerships, policy coordination, or shared mitigation initiatives, becomes the linchpin for addressing the Antarctic conundrum.